Hello, my esteemed viewers. This tutorial forms the first tutorial in machine learning tutorial series. Before we delve into machine learning in full scale, it is important to differentiate between humanistic learning and machine learning. Exactly, this is the task that is being done in this tutorial. I think in order to do this, we need to define as to what learning is. What do we mean by learning? If you browse through the net or if you go through different books, particularly the books that will speak about the psychology or the learning habits of human beings, you will find definitions, huge copious amount of definitions or plethora of definitions. That means definitions galore. However, it occurred to me that these two definitions will completely define as to what learning is. Learning is the relatively permanent change in a person's knowledge or behavior due to experience. Of course, that means this particular definition is poking to the experiential learning. If you learn things by experience, it will bring in permanent changes in the human person's knowledge as well as behavior, or both. Of course, the duration of such change is long term rather than short term. The locus of the change is, and if you go through the incremental learning or the path traced by this particular change, it is the content and structure of the knowledge in memory or behavior of the learner. The change is in terms of structure of the knowledge that is behold in the learner as well as the behavioral patterns. The cause of the change is the learner's experience in the environment rather than fatigue, motivation, drugs, physical condition, or physiological intervention. So that is learning in a some kind of an atmosphere which is very convenient, very convenient for the learner. It is not by force, it is not by fatigue, okay, it is not by somebody's motivation. Okay, learning should happen just like that, just like that. Learning, the second definition is, learning is the transformative process of taking in information that when internalized, the information when it is taken in, it will internalize, it is internalized and mixed with what we have experienced, changes what we know and builds on what we do. It's based on input, the process and the reflection. It is what that changes us. Then if there is some palpable change in human being in terms of the knowledge acquired or in terms of the behavioral pattern, then definitely learning is said to happen. How human beings learn? Human beings learn in various ways. It could be self-learning, or it could be cooperative learning. It could be learning by observation. It is learning by reading. However, it has been established that human learning, the process or learning process varies from person to person. So as far as machines are concerned, if you load a machine with a learning algorithm, and if you load some other machine with the same algorithm, the learning doesn't change from machine to machine. Next, okay, the first kind of learning is observational learning. Humans learn by observing others or observing trends, observing the scenario in front of them, observing some other people doing some other tasks. This is true in case of animals also. Machines can also be made to learn by just observing the data presented to it in terms of similarities or dissimilarities. Okay, and this kind of learning in machines is seen when when the machine is loaded with what are called as self-organized learning algorithms. Self-organized learning algorithms. Okay, and the next kind of learning is called as associative learning. We tend to associate whenever we want to learn certain things. Human beings associate entities with other traits, and thereby learning will happen. They may associate numbers with operations like plus, minus, etc. And lightning is associated with the thunder. This is the learning that happened. Birds flock with a kind of pattern associated and pounce on the prey. They will optimize. Their food, which is seen underneath, that is on the ground. Animals, the wild animals, farm animals, and pet animals are associated with the characteristic features that are befitting to them. This is the learning which happens. So this is an associative kind of a learning. We associate certain characteristic features with certain kind of animals. In a group of varieties of birds, each bird is associated with features that are good enough to separate them, to delineate them, to recognize them. There are algorithms which will make the machine to learn in the same way. These algorithms will make machines to associate the features with respect to the entity. Something like there is a associative memory model where it is possible to feed a computer with the person's name, and the machine should be able to tell the cell number, or vice versa. There are characteristic algorithms, there are associated algorithms which will make the machine to learn some kind of an associative learning that human beings do. So reward and punishment, this is the kind of association. Associative memory models, fuzzy associative memory models, reinforcement learning models. These are all examples of algorithms which will make the machines to mimic the associative learning that happens with human beings. Inductive learning. Inductive learning is the learning which is induced by a teacher. Inductive learning is induced by a teacher. Of course, this is also called as supervised learning. Okay, and we will be taught, and we will be able to learn. The learning is induced to them by guidance, supervision. There are machine learning algorithms that will establish this kind of learning in machines. Inductive learning algorithm, a set of classification rules, and concept learning is the first kind of learning that happens in human beings. Maybe a small child. Episodic learning. Of course, we learn from committing errors. Episodic learning is the process of storing experiences in one's episodic memory, or retrieving that information and using it to improve behavior. It is a long-term memory used to store unique events or episodes from one's past. And fear of dogs, fear of ants, small kids touching the candle, they will never do this. When a small kid touches a candle out of curiosity and getting smitten by this particular candle, will never repeat the same thing, because it is a mistake committed. So there is a learning that happens due to commission of the mistake. Recognition of a friend, this is a memory model, and long-term memory models. And there are algorithms. Back propagation is a typical algorithm which will make the machine to learn from errors committed. Okay, and recurrent neural networks. This is a typical memory model where sequential input is taken and sequential output is given out. That means if you present let us say a set of photographs where horse is running, the output is it's a running horse. Okay, that is a kind of a sequential output, sequential input and sequential output. And if you present some kind of a sound wave, and it will be able to come out with what exactly it is in speech recognition. And there is another algorithm called as Q-learning algorithm. Of course, all these algorithms will be explained very clearly when we take on to that particular topic. Right. Rote learning. Rote learning is just learning by repeated training or repeated referencing, repeated reading, of course, memorizing the things without bothering about the real experience and real content. Learning, that means this is learning without using any intelligence. And there is a rote loop. This in a memory, in a typical human brain, this is called as a rote loop. Learn, attend the examination, forget. Prepare again, learn again, attend the examination, forget. It's a kind of a loop. So we will never recall. If this kind of a learning happens, we will be failing to recall whenever a similar situation arises. So there are algorithms which will be vaguely mimicking this kind of a behavior in human beings. These are all machine learning algorithms called as LMSL learning algorithm, iterative learning algorithms, and brute force learning algorithms. Informal learning. Here the learning happens in a way different from structured formal classroom environment. Informal learners are often highly motivated to learn. They are often spontaneous. The world, in this particular situation, the world itself is the learner's classroom. There are machine learning models which will make the computers, or which will make the machines to learn in a similar way, in an informal way. They are called as self-organized learning models, or coherence, feature maps, and any self-organized learning algorithm can be attributed to some kind of an informal learning that happens in human beings. Mistakes. There is one commonality between machines and machine learning and humanistic learnings. Human beings commit mistakes, as well as machines do commit mistakes, and both of them will commit mistakes. A typical example here is, we have an education system where a student is given over coaching. This is an arbitrary example, of course. Learning happens by memorizing. When a new problem is given to the student, he or she will not be able to generalize. This is what which happens in a learning where over coaching or over training will happen, and this is equated to what is called as overfitting or underfitting or bias in case of machine learning. Okay, and the mistakes committed by human beings while they learn, or while they reproduce, while they apply that to generalize, they will commit mistakes. And in a similar pattern, machines will also do mistakes, and such mistakes are recognized by the terminologies called overfitting, underfitting, and bias. Of course, overfitting and underfitting and bias will be clearly explained in our next tutorial. Okay, before we venture into machine learning deeply. In machines, this kind of learning is called as overfitting, as I told. It will be clearly explained, of course, otherwise it will be pretty difficult to understand this. Okay, and we will summarize this tutorial, and these are all the examples. See here exactly overfitting is represented. This is the learning that happened by the machine, and interestingly all the data falls into this. This is overfitting exactly. And if the new data is presented to the machine, it will be hanky-panky. It will be differently spread, and it will never fit into this particular model that has been developed by the machine itself. This is optimum case of a optimum kind of a learning, and this is which is desirable. This is desirable, and this is underfitting. There is lot of error from the when compared with the values that is predicted by the model that is shown by the blue line. And to summarize, overfitting is curse to humans and machine learning systems. Machine intelligence is limited to the areas in which they are trained, of course, but human intelligence is independent of his or her domain of training. An intelligent human being will be able to solve problems related to unforeseen domains, whereas a machine will not be able to do that. These days, artificial intelligence is all around us. If you have ever used Siri on your iPhone or the live chat feature of a website, you are interacted with AI, artificial intelligence. Yeah, there is another thing that is to be clearly told in machine learning. In machine learning, transfer learning is a technique that reuses a model, that reuses a machine learning model that was created by machine learning experts and that has already been trained on a large data set. Transfer learning leverages or makes users the information extracted from one set of distributions. In humans, data distributions, of course. In humans, transfer of knowledge to students is often done by teachers and tuition providers, let us say. This may not make the students intelligent. But in the case of machine learning, transfer learning makes the transferee, that the machine, transfer learning that happens to an algorithm for a particular problem solving exercise, the transferee is as intelligent as the transferer. In case of humans, transfer learning is will only transfer the knowledge, and it depends on the inherent intelligence of the transferee to enhance his or her problem solving skills. Transferee is as intelligent. That means if you use the model for any machine, it will be able to behave in the same intelligent manner, though the machines are different, because the transferring knowledge, transfer learning, which happens in the form of a model, will be same across the machines. While human beings, no, this is impossible. However, it depends on the innate intelligence of the transferee. Okay, with this we will close. We have tried to delineate as to how human beings learn and as to how machines learn, and we have broadly in a very draft way, we have just come out with kinds of learnings that happens by the machines and associated algorithms. So with this we will close this session, and in the next session we will bring out clearly as to what bias and as to what overfitting and underfitting is. Until then, thank you, bye. If you have liked this video, kindly subscribe to my channel.